Okay, I'm making this quick video with my son eating breakfast in his high chair right here, so there might be some interruptions. But I wanted to talk about horizontal area between curves. That's where we have to measure it horizontally. And you may ask, why do I have to measure it? Why do I have to think of it horizontally? Because you're used to measuring it vertically, and why can't I just do that? Well, the reason being is it's relatively simple. It's actually, if you look in at this slice right here, yep, that's Levi, you'll notice that like right here, you couldn't actually find that horizontal distance because, well, at least not between two curves, because it's on the same curve. This function, or I guess it's not a function, this curve does not pass the horizontal line test, and therefore it's not a function. So we can't really put it with y all by itself. We can only leave it in terms of y. That's right, Levi, where x is all by itself. And so that's kind of how we have to think of these functions. So that means everything is inverted, right? We're used to y being up here, like my height is up here and then this is down and left to right. But now when I have to think of it in terms of y, I have to invert everything. So really now x to the right is my height, you could say, you know? And remember that y goes from the negative down here to the positive. So these are like my low y values, these are my high y values. So this is the starting point, this is the ending point. And when we think about, you know, subtracting the higher function or the top function from, and then subtracting the small one from the top one, which one of these is on top? Well, like at first glance, it feels like this was on top because it looks like it's on top. But remember, we have to think of x now as the height. And so as we move left to right, this is like the top over here. And so as you look at it this way and you think about that horizontal line, this is actually the function that's on the top. So when we go to do this, we need a couple things. We need to know the limits, we need to know these points, and we need to know which function is on top. So let's do which function on top, and then we'll do this point last, because I think this is the easiest thing. So our integral for this would be, I'll just kind of write it right underneath here, would be the integral of, well, what would be on top? Well, the blue one would be on top, so we're going to say 7y plus 18 minus, and then I don't really have an orange here, but the orange one would be on bottom, and we'll put that in parentheses, that'd be 2y squared plus 19y plus 18. And then that's dy. Everything's in terms of y, so it's going to be dy. And remember, these now here, these are y values, not x values. You might be tempted to find the x value, but that's not what we need. We need the y value. So we know the y value of this one, right? That's just 0. So remember, this is negative, this is positive, so we're going in this direction. So the uppermost limit is going to be 0. That's easy. But the question then becomes, what is the lower limit? Well, we'll get to that in a second. First, let's simplify this and we can start eliminating some answers. So if I was to distribute that negative, I'd have a negative 2y squared, a negative 19y, and a negative 18. And I'd still have 7y plus 18. And I'm just going to work out the part inside the integral. We're just simplifying that. I'll add the integral back in a second. But 7y minus 19y, that becomes negative 12y. Negative 2y squared, and then 18 minus 18 is just 0. So that's going to become something like that. Oh, my son's throwing food. I think he's done. Okay, the question now becomes, at what y value do these two curves intersect? Because we know that the upper limit is 0. We need to find this lower limit here. But we can go ahead and probably do a process of elimination here. We know that we're going to get something with negative 2y squared and negative 12y. Well, that looks like that could be it, or that looks like it could be it. So let's go ahead and eliminate the ones that we know are not it. That's not it. Oops, I wanted to use the line. That's not it, and that's not it. We already kind of simplified this. And we already know that our upper limit is 0, so I'm pretty confident that that's not it. But let's just go ahead and prove that that lower limit is negative 6. So to do that, remember, we're just talking about when these two functions equal each other. So let's just go ahead, make a little equation. Let's say 2y squared plus 19y plus 18. If they both equal x, we could set them equal to each other. And we can just do some basic algebra. My son's playing with his camping toys. So we end up with 2y squared plus 12y equals 0. And you could probably see where these solutions are going to go now. One of the first things I would do is just kind of divide everything by 2. That would give you y squared plus 6y equals 0. Then if you factor, you get y times y plus 6 equals 0, making your two solutions y equals 0 and y equals negative 6. Okay, well, we were correct then about our first thought, right? We first thought that the upper limit was going to be 0, and we've proved that to be true. And now we just proved that the lower limit is indeed negative 6, and so we have the correct answer for this one is A. That's all. Just want to make a quick video kind of explaining how that works. Have fun.